Hello students, so we are continuing the same series discussion. So let us continue. Question number 21. Figure gives the xt plot of a particle in one dimension motion. So this is 1D motion and this is position time graph, right? Okay. Three different equal intervals of time are given. So three equal intervals are equal, right? So this is some interval here. You can see that there is some interval of time like this, first interval here, second interval here, and third interval here. Three interval of time is given. Then what they are asking, in which interval is the average speed greatest? They are asking about average speed. Average speed is greatest in which of these, right? Then, and in which is it least? So in which case, which of this interval average speed is maximum and which interval average speed is minimum, right? That is the question. Give the sign of average velocity for each interval, and we have to also give the sign of average velocity. Okay, so let us try this question. Let's try this question. So let us see here, first of all, average velocity. Let us try to calculate. So you can clearly see here in this graph which you can see here, it's like this. So we can clearly see here displacement, right? This is the along y-axis, that is delta x. Along this it is delta t. Here also you can see this is little bit going up and then coming down like this, right? So here delta t is like this and delta x will be little bit smaller. It looks like little smaller. And what about this case? In this case this one is like this, delta t will be definitely same, but delta x looks larger. Delta x looks larger, but it is negative direction, right? Negative direction. So let us try to figure out average. First they are asking average speed. Average speed, let us think about it. So what is average speed? What is the definition of average speed? Average speed, what is average speed? Average speed is distance by time. Time interval is same everywhere, right? Time interval is same, so we need to think about the distance. Okay, so also note that if the body is traveling in the same direction, then we can consider distance as the magnitude of the displacement, right? So first of all, see here the slope of this graph is positive, right? Slope, how do you know whether the body is traveling in the same direction? We have to see the velocity is same or not. So here the velocity in this graph, first interval, velocity is positive because slope is positive. And if slope is positive, velocity is positive, means same direction, it is same direction. So here this delta x which you can see here, which is of course positive because x is increasing. So delta x here it is positive, right? So this delta x which is positive here, this that means displacement is positive in the same direction and path length will be same, right? Delta L and delta x is same, right? So delta x by delta t, right? So delta t is same for each interval, so delta x you have to say. So because delta x, delta L is the magnitude of that, and anyway delta x is positive, so delta L is equal to delta x. Now here delta x is this much, here it is very small, very small. Why it is small? Because it has like gone up and then come down like this. So this delta x here to here, this one delta x has become smaller here. This delta x has become smaller, right? Delta t is same only. So this delta x has become smaller like that. So this is going to be smallest here. What about this case? Here, what about the velocity? That also you check. The velocity is negative only, so slope is negative, so velocity negative. Again, the direction is the same direction. So we can still take the length, no, path length as the magnitude of delta x. Although delta x here may be negative, but we have to just take magnitude. Doesn't matter. So here it will be the largest in this case, third interval. This is the third interval, right? This is the second interval. So if you take average speed, so average speed is largest in this third interval. So in average speed is maximum in third interval, right? And minimum in which interval? Minimum in which interval? If you see minimum, it is in the second interval. So average speed is maximum in third interval and minimum in second interval. Second interval. Okay, that's the answer for this. Now, what about the average velocity? They are also asking average velocity science, average velocity. So here delta x is positive, here also delta x is positive. So average velocities are positive, positive for this case. What about this case? Yes, average velocity, is it positive or negative? Delta x is positive or negative? Delta x means the change of x. So is it positive or negative in that case? So you can see here, in that case the graph is like this. So this is what is delta x, this is delta x, and this is what is delta t for the third one. So here definitely positive, here also positive. What about this? In this case, is it positive or negative? So note that this is negative direction, right? So here if you consider initial point, this point, and you are considering this point, right? So let us say here this value of x will be there. Let us take value like -2, and then it is going to -3. So -2 to -3, the change will be how much? -3 minus -2. So basically it is going to be negative only, and that also you can understand that it is like this way, downward. So this, in the third case, average velocity in third interval, in third interval, average velocity is negative, and in first and second interval, it is positive. Clear? So that's the question. Let us move to the next question. Number 22. Figure gives a speed time graph of a particle in motion along a constant direction. Constant direction in same direction. Okay, speed time graph is given. Okay, three equal interval of time are shown, in which interval average acceleration. Now similar thing, now they are giving speed time graph and they are asking about acceleration, average acceleration, greatest in magnitude, in which interval average speed greatest. Choosing the positive direction as constant direction of motion, give the signs of v and a in the three interval. What are the accelerations? Let us take the question first. So this is speed versus time graph. This is speed versus time graph. Three intervals are given exactly in the same manner. Here also they are giving us three interval and they have equal time. So delta t, delta t, delta t. These are three interval here, right? Second interval, and this is the third interval. Now what they are asking? They are asking, in this interval we have to compare. What we need to compare? Which interval? Average acceleration greatest. Let us first try to think about average acceleration greatest or smallest. How do you calculate average acceleration? This is speed and it is going in the same direction, right? So if the same speed and same means speed in same direction, that means you can say velocity. That velocity direction is not changing. Direction of velocity is not changing, right? So body is going in this way. Like for example, the body is going in this direction, and it's in this direction, velocity direction is same, but speeds are changing. This is how speeds are changing, right? Now let us take this, and they are asking average acceleration. So what is average acceleration? Average acceleration is delta v by delta t. Delta v by delta t, and note that they are asking magnitude. So when you take magnitude of this, you have to take care of this magnitude. So change of velocity you have to take. Basically it is change of velocity by interval delta t is anyway scalar quantity, but delta v can be positive or negative, and here it is going in the same direction. So let us not bother about the direction, we have to just subtract, right? We need to just subtract that speed, we need to subtract. So that means we need to check the change in the speed, how much speed is changing, right? So let us see here, in this first case, delta v, here this is delta v, delta t will be same here. What about this delta v here in this graph? Here delta v will be this one, delta v, and delta t will be the same. What about this term? This I think here it is coming 0. It's almost at the same point. So in this case delta v is coming as 0, right? Delta v is coming as 0. So where it is largest? Here it is largest. Delta v is largest. So magnitude of average acceleration, when we take magnitude of average acceleration, right, this is what it is going, and it will be largest. So magnitude of average acceleration is largest. Largest in which interval? In second interval. Second interval, right? Then what else? Smallest is 0 in that interval, third interval. That's all about average acceleration magnitude. Then what else? Then they are asking in which interval average speed greatest. Average speed. Okay. Choosing the choose the direction as constant direction. Okay. Same thing. They are asking signs of v and a in the 3 interval. So tell me, how do you do that? This part. Average speed. Can we tell anything about average speed? Because this is what? This is speed time graph. Average speed, how do we tell average speed? How do we tell average speed? Because average speed, V average is equal to distance by time, delta L by delta. Delta T interval is same, delta L. So in which interval the path length is more? In which interval path length is more? In that interval only the average speed will be more, right? How do you know path length? How do you know path length? So this is a speed time graph, and from a speed time graph path length can vary under the graph. So area under the graph will give delta L. So out of all these strips you can see this is the longest strip. So this area will be the largest. So in this case average speed will be the largest. Okay, in third interval, in third interval, in third interval, average speed is maximum. Average speed is maximum, right? Okay, what else? Then they are saying that choosing the positive direction as constant direction, whatever direction that velocity is, you choose that as positive direction. Give the signs of v and a in the 3 interval. See, direction of motion means what? Direction of motion means direction of velocity vector. Velocity vector is the direction of motion. Okay, so consider velocity vector direction as positive. Based on that you decide the direction of acceleration and velocity in each of this interval, and what are the acceleration at the point a b c d. They are also asking accelerations on that will come later. First think about the signs of velocity and acceleration in this interval. So note that here in this direction body is moving in the same direction and speed is increasing. Speed is increasing, so velocity direction is then, so acceleration must be also in the same direction. So this interval, first interval, acceleration as well as velocity both have same direction. Acceleration as well as velocity both are positive. Okay, what about this? You can see that speed is decreasing, correct? Speed is decreasing, and speed is decreasing here. So which direction acceleration will be there? Definitely retardation is happening. So if you are considering velocity direction as positive, then acceleration direction will be negative, correct? This is what we can choose. What about this case? What about this case? Here it is going up and coming down. Hmm? What can we tell about this? What about the acceleration of this? What about the acceleration of this case? Are we talking about average acceleration or instantaneous acceleration? Because instantaneous acceleration will be the slope of that graph, right? So slope will not be defined at a particular point, correct? Means slope will be defined at a particular point, but if you're taking interval you cannot talk about slope, right? So if you are saying that the speed delta v is 0 here, right, speed has not changed, so you can say that average acceleration 0. So acceleration, we are talking about average acceleration here, right? Note that this acceleration we are talking about average acceleration. This acceleration is an average acceleration. This is average acceleration. Average acceleration. So here the average acceleration is going to be 0. Average acceleration is going to be 0, neither positive nor negative. Right? Correct. Now what they are asking is, they are now giving instantaneous they are giving, right? They are asking about instantaneous. And note that here speed is there. Speed means in the interval change of speed is 0, but definitely speed is what? Speed is there, right? There is a speed. So speed you can, velocity you can take positive. Velocity you can take positive because velocity is vector quantity, and here average acceleration, which is also vector, that has become 0, right? Now here they are given some points, they have given, right? This point here, instantaneous acceleration is slope. Just take the slope here. This is becoming horizontal, so acceleration, this is now instantaneous. Note that I am now writing instantaneous acceleration is rho a v. Here also when you draw slope, it is like this. So here acceleration also 0. This is again instantaneous acceleration we are talking about. What about c? Here also this point, when you draw, acceleration becomes 0. Slope of this graph, this is also instantaneous. D also this point, this also like this. So here also acceleration becomes 0. This is instantaneous acceleration, right? So these are very, very minute details, and things must be clear from the graph, these minute things, right? Because in sometimes they can ask complicated questions, and if your things are clear, you will be able to answer that, right? Then let us move next. Question number 23. A three-wheeler starts from rest, accelerates uniformly, right, on a straight line for 10 seconds and then moves with uniform velocity. Plot the distance covered by the vehicle during the nth second versus n. N means here time. Okay, like first second, second second, like that. What do you expect this plot to be during accelerated motion? A straight line or a parabola? So let's try to understand first what the question is. Some particle, you consider that as a particle only. This is body, right? It's like a particle. Accelerates uniformly on a straight line for 10 seconds. So first try to think about what is happening. So 10 second, let's say this is 0 second, and then here up to 10 second. 10 second. Acceleration is constant. And what is the value of acceleration? 1 meter per second square. Straight line, okay, 10 second, and then moves with a uniform velocity. After that the body is moving with a uniform velocity. Uniform velocity means in this interval acceleration is going to be 0. You know that if velocity is constant, so acceleration will be 0. Next, how much time further after, then moves with a constant velocity. They have not mentioned for how much time, but after 10 seconds it is just moving continuously, but now the velocity is going to be constant. Okay, right. That means why acceleration has happened between this, because some force might be acting within this interval. There must be a constant force. Because of constant force, there is a constant acceleration. After that, force was removed, so it is going with constant velocity. Okay, plot the distance covered by the vehicle during the nth second versus n, right? Nth second versus, so 10 second was this. After this, it is going with constant velocity. So from where should we start plotting? Should we consider time 0 here or time 0 here? Let's read question. Accelerate uniformly with this for 10 seconds and then moves with, plot the distance covered by vehicle during nth second versus, and they have not mentioned from where we should consider. So we consider 0 from beginning. Here, that means from there, right? Okay. So we need to plot what? Distance covered by vehicle during nth second. Distance. Let us say distance is, um, x, x, and this is time. Now, if I am considering this as x is equal to 0, I can take this as a position also. Note that the body is going just in the same direction, and its direction is not changing. Direction is not changing. So in this direction, if I plot the position time graph, that position time graph can also give us the distance, right? Because body is not turning back. Suppose it is 2 meters, so it has covered 2 meters. Then suppose it has gone like this. So this x, we can find out that x will give us, means change of position will give us the distance moved between two time. So let us plot the position time graph, okay, which will be nothing but like the distance time graph. So try to plot it. Let us move. So you need to break this for 10 seconds first of all. After 10 seconds, it will be different story, right? So for, first of all, here acceleration is there. Acceleration is there. And what is initial velocity? Can we take it zero? Yes. Can we take it zero or not? Because they have not given or given. Starting from rest, yes, they have given. So initial velocity is definitely going to be zero, right? Hmm. So what will we plot the distance during that? Plot this graph. How to plot this? So let us write the position in this case here. Here how will you write? X is ut plus half at square you will write. Suppose body is here at this position, somewhere here. Okay. So before 10 seconds, so x I can write it u is 0, half a t square. Acceleration is what? 1 into t square. So that means this is just t square by 2, t square by 2. So this graph will be t square by 2 up to 10 second. It is going to be a parabola, you know that. And how much will be the position at 10 second? That also you can substitute. 10 square 100 by 250. So up to 10 second it will cover 50 meter. Let us keep in meter and this is in second. So this is a parabola. After that what happens? After that velocity is constant. So from this point onward, if you consider from this point onward, then what will happen? Now speed is constant. So from here to here, this distance which it will travel, that will be speed into time. So speed is constant. How much is speed? So it has got some speed here. What speed it has got at 10 seconds? That speed you calculate. This is speed. This is speed v equal to u plus at, u is 0, acceleration 1 into t. So that is u into t, right? That is the, how much time was here? 10. Time was 10. So this you can say that it is 10 meter per second. It has got this speed. So from here, this distance which will be covered will be 10 into t. After that, you have to do 10 into t. So from this point, if you are starting the graph, 10 into t is going to be a straight line, right? 10 into t is going to be a straight line, right? So that will be a straight line from this point, like something like this, right? A straight line which will be going like that. Okay, so that is the graph. So this graph equation is tan t, and this graph equation is t square by 2, t square by 2 graph equation is valid here, and here this equation of graph is this, right? Clear? So these are two graphs for this. Now what else they are asking? What do you expect this plot to be during accelerated motion? A straight line or a parabola? Accelerated motion means, I think this part, accelerated motion. During this part, they are asking what is the shape of this graph. We already know this is a parabola. Already we told. A straight line is during this part where acceleration is not happening. This one. This one is a straight line, right? And this is parabola. Very good question, right? A lot of questions can be framed from this. And suppose, for example, suppose if they say that what will be the equation of this line equation. Suppose if they ask what is the equation of this line, then how will you write the equation of that line? How will you write the equation of this line equation? So see, note that already x has happened how much? 50 meter, right? So this equation you have to write x is equal to 50 plus 50 plus, because after 50 you are writing, after 50 you are writing, and this is tan t, 50 plus tan t, tan t. Okay, this is the equation of that line you have to consider, right? That is the equation of line. So if time is equal to 0, time is equal to 0, then x has to become, but you don't have to take that, because time will be starting from this point, correct? From this point onwards, time will be starting. That means you need to consider, let us say you consider 10 second. Note that if I put time as 10 second in that equation we should get 50. Are we getting that? Are we getting it or not getting? Not getting. So why? Is that equation correct or not? Because this, now this concept which is coming is shifting of the graph. We know from here only it should happen, right? So after this point means straight line graph has to go. So can we write x equal to 50 plus t? Because if you take time starting from here, then you can write, but this time is not the starting point. Time is starting from here. If time is starting from here, then you can write it. But what modifications should we do in this equation? Definitely 50 should happen when you put time is equal to 10. Yes. What modifications should we do here? Think about it. Should we add 50 or should we subtract 50? Correct. Should we add 50 or should we subtract 50? So basically the equation of this line, if I consider this as origin, suppose if I consider this as origin, then equation of this line should be 50t. Sorry, this one tan t. Equation of this line should be tan t. If I consider this as origin, but that is not the origin. Origin is here. Origin is here, right? So how much distance is shifted in the y-axis? How much distance is shifted in the y-axis? Think about it. Y-axis 50 has shifted, and how much distance is shifted along this? What modifications should we do? This is a very basic of maths only, but how can we apply that? Think about it. Can we write this as? Can we write this as 50 plus 10, but this time is starting after this, so can we write this as t uh, t minus 10, t minus 10. 10 t was there, but this t is starting after 10 seconds. So this, can we write this? Because if you put time is equal to 10 minus 10 0, then it will come as 50. Is this equation correct? Think about it. If this is correct, then what it will become? So you can little bit simplify this, then this equation will become x is equal to tan t minus 100, this minus 50 it will become. Now you see, this is the equation of this line. This is the equation of this line, tan t minus 50. And if you continue, suppose you extrapolate this graph where it will meet the x-axis. Suppose if I put time equal to 0 here, then this line will be meeting as minus 50. So little bit you have to tilt this graph. Okay, this graph little bit you have to tilt it. Little bit you tilt this graph. Tilt means this graph actually should look like this way. Like this way it has to look. Okay, this is a straight line graph which has to look like this way. So when you extrapolate this, this will be coming and hitting this at minus 50. Minus 50. Wow, that is nice, right? They may also say that if suppose this extrapolate this, where this will meet. So these are all the advanced techniques, and they can ask questions. So how can we shift this graph? Okay, this graph was how much? This graph was tan t, and also you have to shift in tan t, you have to shift in this side, further side. So now note that in tan t we have to put minus 50. This is called shifting of the graph. So if you have to shift this graph towards the right side, you have to subtract this distance minus 50. If you have to shift towards the left side, you have to add plus 50. So what we are thinking that we will add 50 because it is starting from 50, that will not be correct. We have to put minus 50. Although now this way we can derive it, because we have written 50 plus 10 into t minus 10, right? Then we have got, this is the correct approach. So now from onwards you can remember that if graph have to shift it towards the right side, then you have to write minus, and if it has to shift towards the left side, it has to be written plus, right? Okay, so fine, let's move to the next question. Question number 24. A boy standing on a stationary lift open from above throws a ball upward with the maximum initial speed he can equal to 49 meter per second, how much time does the ball take to return to his hand? So he's throwing with his speed, right? Some speed he's throwing. Okay, stationary lift is stationary and he's throwing that open from above. How much time it will take? Okay, he's throwing with some speed. How much time does the ball take to return? So this question is a direct question. So body will go up and it will come to his. So what is the total time? 2u by g. We know that. We can substitute. Here speed is 49 and g is 9.8. Remove this 10, right? So this got cancelled. You got 10 seconds. So in 10 seconds the ball will come to that person. Now question is what? If the lift starts moving up with a uniform speed of 5 meter per second, now the lift is start moving up, okay, and the boy again throws the ball up with the maximum speed he can, means same speed. How long does the ball take to return to his hand? Now how much time it will take? Remember that the lift in which the boy is, that lift is going with a constant speed. Constant speed, lift is going with a constant speed. Now this concept is a very important concept of relative motion. So what about the speed, relative speed? You have to consider the same relative speed, 49, right? Correct. 49 is throwing with the same speed, 49. Okay, boys again throw the ball with the maximum speed he can. How long does the ball takes to return to his hand? How much time it will take now? What do you think? Now here to solve this question, this boy is the observer now. Boy is the observer. So note that this boy is not under any acceleration because he is standing in a lift which is not accelerating because it is going with a constant speed or constant velocity upward, right? So acceleration of lift is not there. So he does not have to give any pseudo acceleration or pseudo force, right? So whatever object he is going to study, that object has same acceleration as the downward, right? And he has given speed. That speed of course is relative speed. Relative speed, right? So relative speed is the same speed which is 49 meter per second. So the answer is going to be the same. It doesn't matter, the same answer will be coming here, right? But if the lift is under acceleration, let us say lift is under acceleration, then he has to give a pseudo acceleration. So suppose lift is under acceleration upward direction, so he has to give now effective g has to be taken, effective g has to be taken as g plus a. So the time in that case will change, as time will be changing as 2u by g effective. G effective. So if this lift is under acceleration upward direction, then G effective will increase, and if G effective will increase, then time will decrease. And if the lift is going downward acceleration, then G minus A will happen, then G effective will decrease, then time will increase, right? So you need to see how the G effective changes. In this case, acceleration 0, so no changes happen, right? Fine. Let us move next. Question number 25. On a long horizontally moving belt, a child runs to and fro with a speed of 9 km per hour with respect to the belt between his father and mother located 50 meters apart on the moving belt. The belt moves with a speed of 4 km per hour. For an observer on the stationary platform outside, what is the... Okay, so the question, first let us think about the diagram. Here diagram they have given. So his father here and mother, and the child is going right in between, and this belt itself is moving. Very good question it is. The belt itself is moving, and on the belt the father and mother are stationary. The father and mother are stationary relative to the belt. Okay, correct? Is this the same question? For an observer on a stationary platform, okay, between his father and mother located 50 meter apart on the moving belt, right? The belt is moving with the speed. For an observer on a stationary platform outside, what is the speed of the child running in the direction of motion of the belt? So what is the speed of the child relative to the belt. No, relative to outside. And what they have given, this is respect to the belt. So let's see here, let us write the value. So this child relative velocity, velocity of this child, here I will write velocity of the child relative to belt is given as, and he's going in the same direction, right? That is given as 9. So plus 9 kilometer per hour. And velocity of belt is also positive. Velocity of belt is plus 4 kilometer per hour, right? Okay, then distance is 50 meters between them. Then the belt moves with a speed for an observer outside, the speed of child, right? Outside person, what is the speed of the child running in the direction of motion of the belt? What he will see, the observer, this is the observer who is outside, he is observing this child in this direction, child is moving. So first, how do we calculate this? So that means you need to actually calculate the speed of the child, that's all, child speed. So how do you calculate the child speed? So this relative velocity is given, right? So this is velocity of child minus velocity of belt, right, is equal to 9. And velocity of belt is given 4. So velocity of child minus 4 is equal to 9. So velocity of child is 9 plus 4, 13. 13 kilometer per hour, right? So child is having velocity 13 kilometer per hour. This is with respect to ground. That's the first part. Then what else? The speed of the child running opposite to the direction of motion of the belt. Now suppose the child is running opposite. Suppose the child is running opposite. So relative motion will be now this way, this way. So here only relative, this you have to put a minus sign. You need to put a minus sign there. So velocity of the child with respect to belt you have to put as minus 9. That's all. So substitute there minus. So here minus will be coming. Here minus will be coming. And this minus 4 will go that side. So plus 4. 4 minus 9 will come. So in this case, what will be the velocity of child? In this case, right? So minus 9 plus 4 minus 5 kilometer per hour, right? In this case, second case. So if the child is moving from mother to father in this direction, then this person will see that the child is moving in that direction with a speed of 5 kilometer per hour, right? Then what else? Okay, now next part of the question is time taken by the child in A and B. Okay, now the question is how much time the child will take to reach from father to mother or mother to father. That time we need to calculate. So if you consider this motion, relative motion, so is going from here to here. This distance they have given. How much is the distance? Distance is 50 meters. 50 meter. So first case, if you are calculating time in this case, time is distance by relative speed. So distance is 50 meter. 50 meter by relative speed is here how much? Relative speed, remember relative speed we have to use, which is how much? 9. 9. This is kilometer per hour. Okay, and that is so you can multiply kilometer into 1000, or if you want you can do this as 5 by 18 also to simplify that, right? So kilometer per hour 5 by 18, 18 will come here. Then how much it will be? Cancel out 9 2 and 5 10. That means this will take 20 second. 20 seconds. So while coming from father to mother, he will take 20 seconds. Now reverse also you do. What about reverse? While you're doing reverse, relative speed is the same relative speed, and distance is also same, right? So if the relative speed is same and distance is same, so it will be taking the same time, correct? Relative speed, remember this is relative speed what they have given. So if the relative speed is same and the relative distance is same, so time will be same time he will take to travel from here to there, correct? Because it is relative. Suppose relative speed is not given, then in that case you need to consider, otherwise. Then in that case you need to calculate relative velocity and then take. Note that this father and mother, they are on this belt, so he is moving on some point on the belt. If this father and mother are outside, then calculations will be different. Definitely calculations will be different, because then in that case you need to consider the actual speed of the child, and you can see the actual speeds of childs are different. Actual speed of childs are different. Then in that case, time calculations will be different in both the cases. Fine. So the question what they are asking. Let's move to the next question. Two stones are thrown up simultaneously from the edge of a cliff 200-meter high with initial speeds of 15 meter per second and 30 meter per second. Right. Verify that the graph shown in the figure correctly represents the time variation of the relative position of second stone with respect to first. Neglect air resistance. Assume that stones do not rebound after hitting the ground. Take G as 10. Give the equations of motion and the output. Okay, let us try this question. So what they are saying is that two stones are being projected, and what are the speeds? From a cliff, 200 meter and 15 meter per second and 30 meter per second. So let us take this example here, that there is a cliff, right? So this height is 200 meter, and let us say that this is the first stone, 15 meter per second, second stone, 30 meter per second. Okay, this is the ground. So we have to study the relative motion of relative position of second with respect to first. Okay, so is this graph correct or not? We need to verify also whether this is right or not. So what we need to do is we can write the positions, equation of the positions. Let us write. So you can write the equations of positions relative to one. So let us study relative motion. So suppose if I consider that this is the observer, then he will not find himself, he will see itself rest. So according to that, this will get a relative velocity how much? 30 minus 15, which will be 15 meter per second. This is the relative velocity of 2 with respect to 1. Second velocity with respect to first is 15, because they are going same direction, right? You have subtracted that. So what will be the position? So with respect to this observer, you will see that it is going up, and that position we can now write. And note that till the both the bodies are in free fall, their relative accelerations are also zero. Note that the relative acceleration of 2 with respect to 1 is going to be 0 till free fall. Okay, so acceleration, relative acceleration 0. So that means that has constant relative velocity. So this position graph x2 with respect to 1, that will be velocity into time. So velocity, relative velocity u21 into time, that is 15 into t. So this graph is 15t graph, which is like a straight line. We can see here this graph which is going here like this. This is 15t. They may also ask sometime question, what is the slope of this graph? So slope is y equal to mx graph, slope is 15 here, right? Then what else? Now after this, you can see here that at some time it is graph nature is changing. Why it is changing? That means free fall is no more there, relative motion. Just check that when is the observer will come to ground. Let us try to find out the time when this observer come to ground. Okay, let us try this. So this first object was thrown with a velocity of 15 meter per second from a height of 200 meters. So it will be going up and then coming. So how will you calculate this time when it come to ground? You need to know velocity here. How much is that velocity? Can we calculate? Root under u square plus 2gs. So 15 square plus 2g is 10, and this height is what? 200. So how much this will become? Calculate this. 15 square 225. 200 into 220. So 4225. So this will come how much? 25 root take Try to take that. I think 25 will come 5. 5 square 6 into 7. 42. So 65. You know how to take the squares of numbers ending with 5. So for example, 65 square if you want. So 5 square 25. And next to 6 is 7. So 6 into 7. Right? Like that 42 will calculate. So this is velocity you got, right? When it will hit the ground. So this time can be calculated as this v plus u by g. So 65 plus 15 by g 10. So how much this comes out? 80 by 10, 8 second, right? 8 second. So I think this is what is seen in the graph. In 8 second, this first person will be landing on the ground. The first person will land on the ground, correct? Right. First person has landed on the ground. Then he is starting the body from the ground, right? From the ground. Okay, so that means he is starting from the ground. That observer has now situated in the ground. So relative motion is going to change now. How will you take now relative motion? If this person has come to ground now, so that means from the ground itself the observation is done. So if you study from ground, ut plus half ut square you can apply and check how will you do that. So suppose if this was not come to the ground, right? It was previously here 200 meter. Now it has come to the ground. Before not coming to the ground, it was here. So what will be the relative motion of this, right? Ut plus half at square, can we apply that? Okay, suppose from this position, let us say that this itself is ground. Let us say this itself is ground, this itself is ground. Let us consider this itself as ground. So from here what will be the position of that body, second body? Ut plus half weight square we can apply, and also note that now this observer come to ground means you need to add this 200. So second with respect to first, this will happen after 8 second. After 8 second, this 200 you have to add. 200 you need to add because we are starting from here. And from this ground is ut plus half ut square. So what was the initial velocity when it was projected? Time 0 was the when projection happened. So u was how much? 30. 30 t ut minus half g stand into t square. Check out this much, how much will come. So 200 plus 30t minus 5t square. Correct? Is this equation correct? Check that. If this equation is correct, that 8 second, it is starting from here, like this graph will be coming. Okay, and what about this 10? Is it correct or not? That means this object is coming ground 10 second. That also you check. Same way you calculate this when this second object, because second object was thrown with a different speed. Instead of 15 you have to convert it 30. Take 30 and check the calculation. Suppose I throw with 30, then what will be here speed? Just check this speed. Root under 30 square plus this was 4000. So how much it will? 900. 4900. Yes, 4900 will give 70 meter per second. And calculate the same time formula. It was thrown with 30. So 30 plus 70 divided by 10. So yes, 10 seconds. So you can see that this body will come to the ground at 10 seconds, right? So this graph is correct, and it's a very classical example of relative motion, observing two bodies that under gravity, motion under gravity and relative motion. Good question. It's a good combination of that. Fine. So I hope you got it. Let us move to the next. Question number 27. The speed time graph of a particle moving along a fixed direction is shown. So this is the speed time graph they have given, right? Right. Obtain the distance traveled by the particle between time 0 and 10 second. So time 0 and 10 second. This graph, time 0 and 10 second. So this is 10 second, 0 to 10 second graph. This is 0, 5 and 10. Okay, so we need to calculate what distance traveled by the particle between 0 and 10. 0 and 10 means here to here, right? This is not that, this is a speed time graph. So if this is a speed time graph, then area under the graph directly will give distance, directly will take. So 0 to 0 to 10 second, this distance will become equal to area, which is half into, this is base is 10, right? And what is this height? Height is 12. From the graph we can see that. So from here this will become 60 meter, units are in meter. Okay, then what is next part? 2 to 6. 2 to 6 means 2 will be here, right? 2 and 6 will be here. So now you need to figure out this area. 2 to 6 means you need to figure out this area. 2 to 6. So if you want to calculate 2 to 6, you need this area. Now how will you calculate this area? Think about it. Think about it. So if you know the value here at 2, and if you know the value at 6, then we can think about calculating, because this is smaller areas I can subtract. That is one way of doing. So let us try to do that, try to find out that approach. So what will be this value here, corresponding value, and similarly what will be corresponding value here? That means this length we can calculate, correct? This length we can calculate how much it is. So what is the slope of this graph? This is 12, right? 12 by 5, that is tan theta. So tan theta is 12 by 5, right? And this is value is 2, right? So this by this is tan theta, so this is equal to this into tan theta. So this will be 2 times of this value will be how much? This is smaller portion, this, right? How much this will be? This will be 2 into tan theta. Here tan theta is how much? 12 by 5. 12 by 5. So you are getting from here how much it is? 24 by 5. You got this 24 by. Similarly here also, same way when you calculate here tan theta, this is also same, because this distance is also 5 only. So now you can calculate this length. How will you calculate this length? Same way. This is how much? Note that this is 6 to 10 means 4 it is. 4 into 12 by 5. That will become 48 by 5. So you got this. Now you calculate this small triangle which you want to subtract. So from 60 we are going to subtract this small triangle. This small triangle area will be how much? Half into base. This is 2 into this height which we have calculated as 24 by 5. This get cancelled. We got 24 by 5. What about that area? This area. What about this area which we want to calculate? That is half into base. This is 4 into this height is 48 by 5. So this become 2. So that will become 96 by 5. So these two area, let us add them. We have to subtract from original area. So 96 plus this, how much? This 5 will come as LCM, right? And 9, this 6 plus 4, 10. 9, 9 plus 2, 11, 12, 120 by 5. So how much this will come? Yes, this we can calculate now. So 5 into 2, and this is 4, 24. So 24 you need to subtract to get that area. So from time is equal to 2 to 6, that distance traveled will be equal to 60 minus 24. That is how much? This is 36 meters. Fine. So how to calculate it here? Because the figures are simple, we can do the calculation easily, right? You may also think of calculating this by breaking into two trapezium, but anyway you need to calculate this height even for the trapezium area calculation, right? Let us move to the next. And what else? What is the average speed of the particle over the intervals a and b? So in this interval they are asking average speed. So total distance by total time. So average speed calculation you do for this average speed. Total distance is 60 and time here is 10 seconds. So this will be 6 meter per second. While you are calculating for this interval, average speed will be total distance 36 and time here is 2 to 6 means 4. That will be 9 meter per second, right? This is the average speed calculation. Fine. Let us move next. The velocity time graph of a particle in one dimension motion is shown in the figure. This is one dimension motion, right? velocity time graph. Which of the following formula are correct for the describing the motion of the particle over the time interval t1 to t2? T1 to T2 you want to describe the motion. Remember, it's a one dimension motion. What is moving in a straight line? What is moving in a straight line? Okay. Now, what type of graph it is? Is it a curved graph? What type of curve is it? Is it a parabola? Of course, a straight line is not there. We can see clearly that. We are saying in the interval, right? How to do that? Velocity is variable definitely. So some equations they have given, and based on these equations we have to select which can describe the motion. Which of the following formulas are correct for describing motion of the particle from t1 to t2? So note that if velocity, if acceleration is constant, then this velocity time graph will be a straight line. So definitely we cannot apply the equations of uniformly accelerated motion in this case. Why? Because velocity is changing non-linearly. If velocity changes linearly, then acceleration is uniform, but it's a non-uniform acceleration. So this is what we need to note. It's a non-uniform acceleration. Non-uniform non-uniform acceleration. So for non-uniform acceleration, then you will use in differential formulas or integration you will use. So the basic formula, right? So velocity is equal to dx by dt. If I have to do dx v dt, I will integrate this. So this will be displacement, which will be x2 minus x1. x2 minus x1 will be v dt, right? And I am taking any position here. So my original position, final position is x2. X2 means I will write as x. Okay, x2 I will write as x. X minus x1 I will write. So x will become equal to x1 plus integration of v dt. So original position x1 plus integration of v dt. Integration of v dt gives displacement. So original position plus displacement will give final position in between this interval, right? So let us check that. So x equal to x is equal to. So again, let me write that. So final position in between that interval will original position plus integration of v dt, because this gives the what? This gives us what? That gives displacement plus. This should be correct. This should be taken as correct. So how do we take that? And here I think further is also there. No, this equation is not good. Okay, we'll check that. So first you try to write this. So original position v t2 minus t1 is constant velocity is taken plus half a t square. We cannot take that. So first one is definitely wrong. What about the second one? V equal to, can we use v equal to u plus at? This also we cannot use because this is for uniform acceleration. We use v equal to u plus at. Average velocity. Average velocity is always right. Average velocity is delta x by delta t. So this is always correct. Average velocity is displacement over time. Okay. What about this average acceleration? Average acceleration is what? I think this is v2 minus vt1 should be there, correct? Because this final velocity minus initial velocity, change of velocity by time interval, then this can be correct. What about this? Is this going to be correct or not? Again, here average accelerations they are using. So can we use this approach? Final position? No, we have to use this only. We need to use this only. Final position x2 is initial position plus displacement, right? This is also not going to be correct. And if this displacement is given as integration of v dt, then we can treat it constant. Fine. So here we can understand we have to use differential equation. And if you are writing acceleration you have to use as dv by dt. dv by dt. Then you have to write dv is equal to a dt, And here also, if you are writing change of velocity v2 minus v1, that will be integration of a dt. So final velocity can be written as initial velocity plus integration of a dt. These are, equations for non-uniformly accelerated motion. Non-uniformly accelerated motion we can write. But average velocity, which is always displacement by time, which is x2 minus x1 by this, right? Similarly, average acceleration is delta v by delta t. This average formula will remain as it is. Correct? Fine, let us move to the next. Then comes NCERT exemplar. So let us see NCERT exemplar problems, how to attempt that. Among the four graphs figure, there is only one graph for which average velocity over time interval 0 to t can vanish for a suitably chosen capital T. Which one is it? So they are saying that the average velocity, for which average velocity over time interval 0 to 2 can vanish. So average velocity is what? Average velocity is displacement delta x by delta t. Average velocity becoming 0 means displacement is going to be 0. So you need to think that in which of this graph displacement can become 0. Displacement becomes 0 means original position and final position are same, right? Think about it. Which graph can give us, right? So first graph, if you see, so it has started from negative position and then it is going like this, and they are saying the interval 0 to t. 0 to t means you have to start from 0. So original position is this here. Will it be able to reach at this position? No, because this point is going further. So this body will never come back to this position. So displacement can never be 0. So you can reject this one. What about this one? It is starting from here, and when it will come back, you can see that again it will be coming to this position, right? At a different time it will come. That time interval will be this, right? Some time will be there. So at this time when it comes, so in between this and this, so that is capital T. I think they are asking that interval 0 to capital T. So this time is 0 and this time is capital T. So in this interval, initial and final positions are same. So this will happen, right? What about this? This will also not happen. And what about this? This will also not happen. So this is the graph where original position and final position are happening. Sometimes it may happen more than one time. So if the graph is bending more and again coming to the same, so average velocity can become 0 again after some other time also, right? Let us move to the next question. A lift is coming from 8th floor and is just about to reach 4th floor, taking ground as origin as positive direction and positive direction upward for all quantity. Which of the following is correct? Now this is about no velocity or vector quantities. You have to check this sign. So suppose I am taking ground. Here the ground is origin. This any point you choose as origin, and you have to choose upward direction as positive. Right, upward direction you choose as positive. So what they are saying is that the lift is coming from 8th floor and is just about to reach 4th. So lift is going downward. Okay. So originally the lift is here. It is on the 8th floor, and now it is going to come to the 4th floor. 4th floor. Okay. So a lift is coming from 8th floor and is just about to reach 4th floor. That means lift is moving this way, downward it is moving, right? Just about to come means it is going to stop, right? Note that this is important thing. So it was moving and it is going to stop. That means its speed will be decreasing. Note that its speed will be decreasing. It is going down and its speed is decreasing. Okay. Right, taking ground as origin and positive direction upward for all quantity, which one of the following is correct? So first they are saying this x is represent the position. This position will be measured from here origin. So if you measure this position, so while the body is moving, either going up or down, in any case this body is above ground, right? So x can be positive always. So x has to be positive. Let us write x has to be positive in all cases. Then they are asking velocity. So because this body is moving downward, the lift is moving downward, velocity has to be negative. velocity, because direction is downward, right? Velocity is negative. What about acceleration? Now this is the most important thing, acceleration. Acceleration is most important. So the body is going downward. Body is going downward and its speed is decreasing. Note that downward motion, velocity downward, and its speed is decreasing. So definitely acceleration must be opposite of velocity, and because velocity is downward, acceleration must be upward, so acceleration must be positive. This is how we can think about it. Okay, acceleration will be positive. So let's choose that. So this positive, 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 then velocity, velocity is negative. That means this option. So option C, this is the correct option. Got it? Let us move to the next. Question number 3. In one dimensional motion, instantaneous speed we satisfy. So let's say body is moving and the speed is in between this condition, right? That means it is smaller than a particular velocity. The displacement in time t must always take non-negative values. The displacement x in time t satisfy this condition. The acceleration, so whether this is moving with a constant speed or not, in one dimension motion, instantaneous speed satisfies. So speed is lying below a particular value. Okay, speed is below. Now they are saying displacement in t, in time t, must always take non-negative values. What does that mean? Displacement must be non-negative. Yes, this is the speed. Speed must lie within that. So the body may go either left or right, we are not sure, right? Because they are talking about the speed. So you may choose that body may go this way or body may go this way. It doesn't matter, but the speed must lie less than a particular value. Displacement in time t must always take non-negative values. Displacement, when we talk about displacement, we can think of drawing the velocity graph. Now, if I draw the velocity graph, let us say body is going this way, then I will keep velocity here, right? Let us say this is V naught. So velocity will, this graph, if I take V naught, velocity will be less than that. And if I take a time interval t, right? So the area that can happen, maximum area that can happen is this one. Of course, it will be plus, right? And maximum area that will be V naught into t. So maximum displacement I can take V naught into t, right? If the body is moving positive, so it will be positive displacement, but if body is moving negative, then it will be negative displacement. The graph will be below, right? So the displacement in time t must always take non-negative values. Not correct. Why displacement has to take non-negative? Non-negative means what? What is meant by non-negative? Non-negative means what? Non-negative can be 0 or positive, right? So it can be negative also if the body is moving this way. So displacement can be negative, right? Next part, displacement x in time t satisfies. Displacement satisfies. Now see, they are saying that this is the maximum displacement v naught t, and suppose if body has zero speed, then it will have no motion, and it is greater than equal to minus v naught t. Why greater than equal to? Because this velocity is less than v naught, either positive side or negative side. If you consider negative side, then what will happen? I am drawing in the same graph. In the same graph, you can take minus v naught then, and it will be like this. Then in that case, you have to consider this as maximum area. So why should we take equalities? Equalities we should not take, correct? Why? Because here it is not equal to V naught. So velocity is less than that. So the displacement will be also less than that. In extreme case, if you consider equality, velocity become equality, then here equality should also be given. But they have not given that. So this equality here which is coming, this is not correct. This is not correct. Otherwise, it can go this side also displacement, that side also displacement. So displacement can happen either this way or that way. We can take that. But because of this inequalities, we can reject this one. Then the acceleration is always a non-negative number. Acceleration. So what they are saying, this is instantaneous velocity. So non-negative means, again, that means it should not be negative. Acceleration is not negative. So what is negative acceleration means? So why not speed can increase in that way? Suppose a body can have a, let us say if I have chosen this direction as positive, we can have acceleration also this way. Acceleration can be negative. Why not acceleration can be negative? We can have negative accelerations, correct? And velocity can also be negative. Velocity can be either positive or negative, we have seen. So acceleration can also be negative or positive, anything is possible. So again, always this condition always can be rejected. Then what, the motion has no turning points. No turning points means what is meant by no turning points? Motion has no turning point. So turning means, suppose the body is going with the velocity v and it is changing its velocity, right? For example, suppose if body is going like this way, then if it is taking a turn, so suppose here velocity is positive, after that velocity will become negative. So if velocity is zero somewhere, if velocity can be zero somewhere, then there must be a turning point. So check that in this question, is velocity is 0 here? Yes, velocity is equal to 0 here. Velocity is equal to 0. So motion has no turning point. This is also wrong. So which one can we consider as correct? Is this inequality not true? Maybe here if it is greater than, then we can go for that. If it is greater than here, otherwise equality we cannot go for that, right? Fine. Then let us move to the next question. A vehicle travels half the distance L with speed v1 and the other half with speed v2. Then its average speed will be. So what they are saying, that a body is traveling with, right, distance L with speed v1. So suppose some distance L it is traveling with speed v1. Then next, other half with v2, other half. So a vehicle travel half the distance L, half the distance means L by 2. Here also L by 2, and this is speed v2. This is a direct formula based, right? But let's understand how to solve similar type of questions. So note that here distances are equal. Let us say in general the body is traveling x distance, then next x distance, and next x distance, like this with different speed v1, v2, v3, like that. Equal distances, right? So this can be taken as equal distances. Equal distances. So what is the average speed formula? Average speed is what? Total distance. Total distance by total time. Suppose it is n motions are there, x, n times x will come, right? And then time. So time in individual time is distance by speed. So x by v1, x by v2. Like that you will be adding x by vn. So in general, you can write this as n divided by 1 by v1, 1 by v2, like this, plus 1 by vn. This is what? This is harmonic mean. So this will be harmonic mean. This is called harmonic mean. We can calculate that. So here, of course, they have given two motions. So what it will be? You have to write average velocity as, how will you write average velocity here? Two motions are there, so average velocity you have to write as 2 divided by 1 by v1 plus 1 by v2. So this will become 2 v1 v2 by v1 plus v2. But this formula holds true for general and number of motions, right? So 2 v1 v2 by v1 plus v2. Similarly, if the body travels in equal time, then what happens? Let us say that case also. If the body is traveling equal time, equal time. So it is traveling for t, 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 like that. Okay. So this is the first velocity v1, v2, v3, v4, like that body is traveling, right? But distances are not equal now, distances will be different. So average, how will you calculate average? Total distance, now distance you have to add. So distance first case is v1t, next case v2t. All these distances you will be adding vn t, right? This is the nth motion, let us say, divided by total time. Total time is t n times t. So you will see that this is the what? This is the arithmetic mean. This is arithmetic mean. So in such cases, if body travels in equal time, then this is arithmetic mean, right? If body travels in equal distance, it is harmonic mean, right? Let us move to the next. The displacement of a particle is given by this, where x is meter in t second. The distance covered by particle in first 4 second. First 4 second. Note that this is a very good question. They are asking what? They are asking distance. Very, very critical question it is. Very critical question. Like this type of question comes in JEE as well as NEET. So they are asking distance. Remember, they are not asking displacement. So if they ask displacement now, then it is very easy graph. Integration you can do, but here you cannot do integration, right? First of all, you need to figure out whether distance displacement is same or not. If the body is going in the same direction or is it changing its direction? How do we know whether changes direction? Wherever velocity becomes zero, that is turning point, not turning point. Turning point means velocity is zero. So first calculate velocity. So velocity is dx by dt. You differentiate that. So when you differentiate, 2 will come out, correct? 2 will come out and this will become t minus 2. This is when can velocity be 0? Velocity can be 0 very clearly. We can see when time is 2. So 2 second velocity will become 0. So in such case, if you have to calculate distance, so let us also see that if time is greater than 2, then only it is positive. Less than 2, it's negative. So initially, what is happening, what is going this way, what is going this way initially. So time 0 up to time 2, up to time 2, body is having negative velocity, but after 2 second body has turned. Now velocity is in positive direction. So previously velocity is negative, afterwards velocity is positive. This is the main thing here. So you need to think about what is this and what is this. So you need to do the integration, right? And also before doing anything else, also see whether this is a uniformly accelerated motion or not. So can we calculate acceleration also? Because it's a parabolic, right? Second order graph is there, so definitely acceleration will be constant. You can calculate acceleration. dv by dt you do. So 2 will come out, to differentiation is 1. So you got 2 meter per second square. So that means it's a uniform acceleration. So you don't have to worry. You can calculate from here to here, here to here. These distances will be same. 2 times you can multiply that, right? So this distance you calculate. So 2 times you have to multiply this distance. This distance is how much? Ut plus half at square you can apply. So what is the initial speed? Initial speed means here when time is 0. When time is 0, what is this speed? Yes, you can apply. The time 0 means this is going to be minus 4. So minus 4 ut, right? So initial velocity is minus 4 and time you are taking how much? Time you are taking for 2 seconds. So u initial velocity is minus 4 ut plus half a. Acceleration is how much? 2 into t square. T you are taking for 2 square. So these two got cancelled. So 2 into, and note that you have to take this magnitude. This cannot be negative. So you are going to take magnitude of this. So calculate this how much. This becomes minus 8 plus 4. So this is going to give us minus 4. That means 4 only. 4 into 2, 8. 8 meters. This is what is distance. If they ask displacement now, if they ask displacement, so what they are asking, covered by 4 seconds. So that means 0 to 2 and 2 to 4. Again, it will be coming back here only. So that's why we have multiplied 2. But if they ask displacement now, then it will be 0 only, right? Because it is 0 to 2 for this side, and then again right side same distance. So then in that case, forward backward displacement get cancelled, total displacement will become 0, right? Interesting question, right? Then let us move next. So here the answer will be 8 meter. Let us move to the next. At a metro station, a girl walks up a stationary escalator in time t1. If she remains stationary on the escalator, then the escalator takes her up in time t2. Time taken by her to walk up on the moving escalator will be. Good question, relative motion related question. So, girl walks up a stationary escalator in time t1. So, some length of the elevator will be there. Let us say that elevator will have some length, x length it will be. X is the length of the elevator. So, on a stationary elevator, she is able to walk like this. If she remains stationary on the elevator, then the elevator takes her up in time t2. Right, so what are we finding here? Relative means this is relative to that escalator she is walking this, and if she remains stationary on that escalator, so this case which they have given, so this she is walking, right? So in this case, this lift or the elevator is stationary, so it is relative motion. So this is the relative motion of this person, right? Relative motion I am writing, relative motion. This relative motion is x by t1. Note that. And second case, this lift is given. Lift is moving. This is the speed of lift in time t2. So this lift or elevator speed is given. How much? X by t2. This is relative means what? This relative means it is velocity of this girl relative to elevator. Relative to elevator. So this is velocity of girl with respect to elevator, and that is velocity of elevator. What we want to know, the time taken by her to walk up on the moving escalator will be. How much time she will take to move up? Yes. Time taken on moving elevator. So if we want to find out the girl velocity, what will be the velocity of the girl? So you know velocity of this girl will be velocity of girl with respect to elevator plus velocity of elevator. So we can calculate this one, x by t1 plus x by t2. This we can do. This is the relative velocity. Now if the girl is going, right, so how much girl will take, that time will be distance by this speed of the girl. So if I take this one, how much it will be? X will get cancelled, right? So 1 by t1 plus 1 by t2, that means it will come t1 t2 by t1 plus t2. Note that in this question, okay, so we are getting this option C. Note that now we will try to think in a different way. This is general approach when we apply. Now here there is confusion. What is the confusion? They say that the girl walk up station, the elevator is not moving. That means this will be the speed of the girl. If you think like that, let us say we are thinking it like this. This is the speed of the girl. Girl speed I take as x by t1, and elevator speed I take as x by t2. Now the girl is walking on that elevator which is also moving. So now let us take relative speed. So relative speed of girl with respect to elevator will be what? Velocity of girl minus velocity of elevator. So that will be x by t1 minus x by t2. This is one, right? Relative velocity. So now if I consider time, and she is walking over that relative speed, so now with, if the girl is going on the elevator, now elevator is also moving and girl is also moving, right? So with respect to ground, suppose if I am saying, right, so with respect to ground means girl's speed you will see, and with respect to this, if you see, you have to see the relative velocity. So now with respect to what should we see, that's also important. Suppose I have taken it like that. Okay, this is the girl speed and this is the elevator speed. Then I want to consider relative to the elevator. So elevator have to stop. So if if I stop that, then this will be the relative speed, and this length is x. If I take, then in that case time will be x by this relative speed, x by t1 minus x by t2. So x's will get cancelled, t1 t2 by t2 minus t1. Now which one can be correct answer? Because this is I think also in the option, t1 t2 by t2 minus t1. Is this correct or is that correct? Which option can be correct? Because in sometimes in the questions in the language they also give whenever they give in relative this in for example in relative motion sometimes they give in still water. In still water that velocity is taken as relative velocity. Note that when water is still, suppose a boat is there and that relative speed and they have given speed of boat in still water means you do not take that speed of that boat as speed with respect to ground. You take that with respect to what? With respect to water. That's what I have done here first. So what they have given that with respect to stationary scatter means that I have taken as relative. That I have taken as relative. Okay, and then this elevatory speed that is given. So according to that I have calculated actual speed of the girl with respect to ground, and then I am calculating this. Okay, so is this correct or that correct? How do you decide that? Yes, which can be correct? So what do you think? What can be the correct reason? So here, which can be the correct answer? So let's try to understand why do we use this as relative? Why do we use this as relative? And we should note that this is correct. So whenever they are using this word that a girl walks over a stationary elevator, that means it is relative to that. You have to keep that elevator stationary and walk, although the that may be moving, right? So, like for example, the boat problem, as I told, the boat speed of boat on still water is nothing but it is the relative speed. That's the language, right? And also note that when you are trying to calculate this, right, when you are trying to calculate this, like for example this is the elevator of distance x. Now here you note that if this is a point on the ground, let us say this is point on the ground and this is another point on the ground, a and b are on the ground, but this elevator is moving. So let us say on this elevator if there is a girl, right? So when you are studying the motion of this, right, um, of this girl on this elevator, but you are studying from the ground. So from the ground you have to study the motion of this. So what we have seen here that this girl, for example here when you have studied this girl velocity with respect to elevator, in that case you have not considered a motion from ground to ground. We have to take the motion from point A on ground to another point B on the ground, because this length x is the length of the elevator as seen from the ground, right? So we have to calculate with respect to ground all the calculations. So that is why this solution is not going to be correct, right? So we cannot take this solution correct because language we need to catch in the question. So when they are saying that in still water or stationary, right, that is the relative speed, and using that relative speed we have to calculate with respect to ground. Velocity of girl with respect to ground we have to calculate, and the distance we are measuring from ground. So that's what we have to use this when time we are calculating. This is the main calculation which we have to do. So this is the speed of the girl we have to consider, not the relative speed here, right? Clear? So this type of confusion comes, and this clarity is needed in such type of problems, because interpretation can become different and things will go away wrong. Okay, let us move to the next question. Number 7, the variation of quantity A with quantity B plotted in figure describe the motion of a particle in a straight line. Right, quantity B may represent. So these two quantities graph they have given. These are two graphs they have given, right? So what are these quantities? So this quantity is A here and this quantity is B here. What are the possibilities of this? They are asking. Let's see what are the options they have here. Quantity B may represent time. So the graph is like this, right? This is A and this is B, and the graph is starting from here. B may represent time. Yes, we can represent time definitely, because we're starting from zero value, right? Time is equal to zero. We can take that as time. That is possible. Quantity B may represent time. Quantity A is velocity if motion is uniform. Quantity A is velocity if motion is uniform. Suppose this is time and this is velocity. So velocity will be then changing. How can velocity be uniform, or motion can be uniform, right? So uniform motion means velocity constant. Velocity constant. But here if you represent this velocity, then velocity will be changing. Velocity will be changing, then this cannot be considered as correct. Okay. Quantity A is displacement if motion is uniform. So if it is displacement time graph, let us say it is displacement time graph. So the slope will be constant, then velocity will be constant, then it is a uniform motion. Then we can consider this as correct. So C is possible. Quantity A is velocity if motion is uniformly accelerated. Yes, if it is velocity time graph, right, then the velocity time graph slope is constant. That means it's a uniform acceleration, right? So this is also correct. Okay, so it's a multiple choice. Let us move next. Question number 8. A graph of x versus t is shown in figure. Choose correct alternatives from below. Okay, graph is here also given. The particle was released from rest at time 0. So this is position time graph is given, and we need to figure out what can be the conditions. And you can see here that graph is first going like this straight, and then it is going like this way it is going, right? And this is going here like this way. So from this graph we can understand something, that here x is becoming 0, and again x is becoming 0. Two times x is becoming 0, right? These things we can understand. Let us check that. So particle was released from rest at time 0. Rest means what? That means velocity has to be 0 initially. So is the velocity 0 initially? How do you know velocity from position time graph? Slope of the graph. You check the slope of the graph, you see. So initially you can see here, very important, that this slope is like this, no, horizontal. So that means slope is 0, right? Slope will be 0. So here slope is 0, and where here also slope is 0. There are some positions where slope are 0. Here also slope is 0, and I think here also slope is looking like 0. So there are some points where slope looks 0, their velocity will be 0. So definitely initially velocity is 0, right? So initially the rest condition, this is correct, we can take this. And b, the acceleration is greater than 0. Acceleration is the double differentiation of position. So you know that if double differentiation positive means shape is concave, if double differentiation is negative means it is convex. So this acceleration represents double differentiation. So double differentiation positive means concave graph should be there. So at B they are asking. Let's check at B. At B we can see this graph is convex graph. Convex graph means retardation will be there. So definitely here we can say that this is not correct. This is not going to be correct. Then at C the velocity and the acceleration. At C the velocity and acceleration vanish. C. C is what? C is a point here. I think you can note that at point C there is a shape change is happening. Now you should note very clearly that suppose if this type of graph is there and this type of graph is there, wherever shape is changing. Okay, so this point, this is position time graph, x versus t graph. Okay, so we should know that acceleration is double differentiation d square x by dt square, and velocity is dx by dt. So velocity will be given by slope of the graph, and shape of the graph concave convex, that will give acceleration. So if you see for example this position, this graph, this entire region here, this is concave. Concave means acceleration is going to be plus positive, and convex means acceleration will be negative. Here also acceleration will be negative. Now this point, if you see here, this point where it is changing, right? So at that point, double differentiation 0 means acceleration is 0, 0. These points are the point where the shape of the graph changes. So clearly you can see at this point shape of the graph is changing. So you can definitely say that here acceleration will be 0. Here acceleration will be definitely 0, we can say, but slope is not 0 because graph is not horizontal. At least that is what we can see from here. It is not like a flat graph. So acceleration 0, but velocity is not 0. Velocity is non-zero, we can say that. So the velocity and acceleration, velocity does not vanish, so acceleration becomes 0, that's right. Velocity is not 0, so this is not correct. Next, average velocity for the motion between A and D is positive. Average velocity between A and D, A and D. So where is A? A is here and D is here. So average, they are saying average velocity. Velocity is not, velocity is displacement by time. So what is the displacement here? It is going from initial to final, so final value is 0, right? Initial is there, so displacement is negative. Note that displacement is going to be negative from A to D. A to D motion, if you consider, displacement is negative. So velocity, average velocity, when you calculate delta x by delta t, this is also going to be negative, right? It won't be positive, right? So average velocity is positive, that is not correct. Then what is the speed at D exceeds that at E? So they are talking of instantaneous, right? Magnitude of instantaneous velocity is called speed. So at D and E we have to compare. So D means where? Here, D, and E means here. E we know it is 0 only. E velocity is 0. D velocity is there. Of course velocity is negative because slope is negative, but magnitude we can compare, that is speed. So speed is larger here. Here speed is 0, so D has more speed. Speed at D exceeds that at, this is correct, so this is the right. So you can see multiple no choice questions. So if you are solving such problems, your concept will become ultra clear, because then you will be able to judge what is right and wrong. Otherwise, there will be always confusion. So NCERT has given exemplar questions which will make your concept fundamentally strong if you are solving those. Let us move to the next question. Number 9. Question 9, for the one dimensional motion described by x is equal to t minus sine t. Okay, some equation is there. Then what they are saying, x is positive for all value of t positive. Is x positive for all? How can we know whether it is true or not? Velocity is positive for all. We have to plot this graph, right? How can we plot this? Try to plot this. So let us try to this, they are checking your mathematical skill. So we will plot separately. So first plot xt graph. If you plot x versus t graph, let us say if I plot this straight line first, so x is equal to t is a straight line which will be looking like this. We are taking only positive time, right? So like this. And then what about sine t graph? How does sine t graph goes? Sine t graph, here it will be 0 only, but somewhere it may go like this way, like this. Correct? Like this sine graph, Now we have to do t minus sine t. X is greater than 0. X greater than 0 means what? X greater than 0 means what? So suppose if I say x greater than 0 means t minus sine t is greater than 0. That means t is greater than sine t. Okay, so you can see here that where will be greater than means t means this graph, green color graph is t, and sine t, you may represent this with different. Let us say that this is a function which is y equal to t, this is another function, this is y1 equal to t, this is y2 equal to sine t. Two functions are there, this function value should be larger than that. So when is this larger than this? So you can note here that at this point it is smaller, correct? If you are seeing here this point, for this point up to some value where you can equate that, where you can equate t equal to sine t, and of course 0 0 is one point where they are matching. 0 equal to 0, right? And there will be some point where another they will match, correct? So when it is happening, that also you need to see. Okay, tell me, when is t equal to sin t? Can t equal to sin t at some values? Is it possible? That we need to think about it. Think about it. Is it possible? Generally we write sin theta as theta for theta very very small, but can we write for some values? Can we solve the point where it is meeting? How do we decide whether this graph is correct or whether this graph is correct? I'm showing now rough like this, whether this graph is correct or whether um, this graph is correct. How do we know that? How do we know whether it is just touching only at this point or will it also touch another point? Because if you take definitely at 0 0 they will satisfy, correct? When time is 0, and because you want no x value is 0, so at 0 value time is 0 t 0, it is satisfying. Okay, both will be so these are like two graphs. Okay, this t is like one function and it is both will be equal at 0 0 0 value. Definitely they are equal. Can they be equal to at any other points? That we have to think about it. How do we know that? How do we know? One thing is that let us try to think about the slope of the graph. That is a mathematical technique. We can try to think about the slope initially. Let us say if initially the slope of this graph, straight line graph, is larger than slope of this sine graph. If it is like that, then they will not be touching again. Only one time touching will happen. But if the slope of sine graph is larger, for example, here in this case, you can see that if I draw the slope here, slope of sine graph is like this, huh? And this slope will be larger than this line. This line slope we know 45 degree, we know that, right? Because this graph is like y equal to x graph. This graph is like y equal to x graph. So here's the slope theta, that is tan 45 degrees. So slope is equal to 1. Slope is 1. What about this slope? Let us try to take the slope of sine. So differentiation of sine x with respect to x, that will become cos x. And at 0 we are taking, at 0 will be what? At x equal to 0, this slope also is becoming, right, differentiation of sine x by x with respect to x, that cos 0 is also 1. So that means both the tangent here and this line must coincide. This tangent and this line must coincide. That means it is not going to touch at any other, cut at any other. So this graph, this is not going to happen. Okay, note that this will be not going to happen. This graph is not correct. So we need to think like this only. At this point, the tangent which you are drawing, this line itself represents the tangent. That means it will not cut at any other point because tangent only touches that. So this itself is like no t, y equal to t it is, and this is y equal to sine t. So when you are subtracting, this is the equation, right? So they are not going to cut, only one point they are touching it, that's all. So now check here what they are saying. X is greater than 0 for all. So this graph, right, is positive, means this t is greater than this for all values. Can we say for all values it will be? Yes. Can we decide it like that? Is it greater than all values? All values of t. Suppose at any time t you take in this, right? Let us say this is the graph now. This is the wrong one. Let us remove this. Okay. So now suppose if I draw this graph again and try to take this x versus t graph, and now we know that this will be the tangent of 45 degree, and this graph will be going like this way, like this. Now they are saying that will it be larger than for all values? Because see, when you are going from here to here, For all points it is larger, and after that definitely it is going to be larger only, right? So it is just going to be larger, 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 right? So the straight line, for any instant of time you take, this is larger only. Very good question it is, right? For all time it will be larger. We can go for other. Okay, this is all about XT. Now VT we have to also see. So such a nice question it is. We are neglecting NCERT exemplars and all. So nice questions are there which requires lot of time, thinking, analysis, right? Let's go for this velocity. Velocity, how will you do? So if this is x is equal to t minus sine t, so same way let us do velocity. Velocity is differentiation, dx by dt you do, dx by dt you can do. So here differentiation of time is 1 minus sine differentiation become cos. Now they are saying that velocity is positive means what? Velocity is positive means 1 is greater than cos t. That means cos t is less than 1. Cos t is less than 1. Cos t is less than 1. So is it true for all value t greater than 0? T greater than 0. Suppose you take t0. T0 means then cos 0 1 will happen, then it will not be true. But if you take any value of time greater than 0, so some angle will be there and cos will always be less than 1. Less than 1. But can cos also become negative? Even if it will become negative, still it will be less than 1 only, right? So cos will be maximum value is 1, that happens at 0, but 0 they are not allowing. That means this statement is also correct. But how do we visualize from the graph? That means nothing but the slope, right? Slope. So slope of this graph you can see it has become slope is maximum as tan 45 degree, one that is happening. Here it is slope. So can the slope become equal to this? Means the slope is greater than this? Greater than? Yes, if you take any point on this graph and you check the slope. So the slope of this is always greater than, except this point. That's what they are saying. Except means greater than 0. All other points, if you calculate the slope, all other points, if you calculate the slope, slope should be greater than, slope means this. That means when you are doing differentiation. So slope of that sign, that means cos, is less than 1. But also note that there will be some, like for example, suppose you continue this graph. Suppose if I continue this graph I will draw a little bit properly. Hmm. This graph I will draw a little properly, like this. Now suppose if I take a particular time here, because see graph will give better ideas. If you take for example here, this point, so slope at this point will again be like that, no? Yes, can you understand? Because slope here, now one cycle will happen, so slope here will also be same, right? Then that will not be correct then. Yes, for time greater than 0 they are saying this velocity is positive. Velocity positive means this differentiation is greater than this, right? But we can see that cos also become uh, not only time 0, because mathematically by looking it looks like 0, but there are many other values of right, because it's a cyclic function. So many other values of time where cos will become 1, right? Not only 0 but other than 0 also some value of cos, like here in the graph we can see one cycle get completed, again the slope will become equal. So then this we cannot strictly take that. Okay, this we cannot take that. Such a nice question, mathematical analysis they are seeing. How can you analyze this? Next, uh, acceleration is positive for all, again same way acceleration they are taking. So now velocity we have calculated, right? This is velocity. Now let us take acceleration. Acceleration, how will you do? You will do differentiation of velocity, dv by dt. Differentiate this, one differentiation 0, cos differentiation will be minus sine t. So this acceleration comes as sine t. Acceleration comes as sine t. Now acceleration graph definitely you can plot. Acceleration graph is like a sine graph. Acceleration graph is like a sine graph, correct? Right? Acceleration is like a sine graph. Now acceleration is positive for no, we can see somewhere acceleration is positive, somewhere negative, so this is not correct. Definitely you can reject this. Velocity vt lies between 0 and 2. Velocity lies between, what is velocity? Velocity, we have calculated this. Now they are saying that velocity lies between 0 and 2. How can we check that? So what is the maximum value of cos and what is the minimum value? You can think about this. So cos has maximum value of what? 1, and minimum value of -1. So from here you can decide maximum value of velocity. So maximum value of velocity can be written as, so cos you are subtracting, if you subtract minimum cos is -1. So -1 it becomes minus minus plus, so this will become maximum 2. Similarly, what is the minimum value of this? Minimum value will be what? Minimum value cos has maximum as 1, 1 minus 1 0. So yes, velocity will lie between 0 and 2. Velocity will lie between 0 and 2. Correct. That is right. Between 0 and 2 means it can include that also, can including 0 and 2. So we can take A and B as correct, right? Then let us, a spring with one end attached to a mass and the other to a rigid support is stretched and released. Magnitude of acceleration when just released is maximum. Magnitude of acceleration when at equilibrium position is maximum. Speed is maximum when mass is at equilibrium position. Magnitude of displacement is always maximum whenever speed is minimum. So let us try to understand this diagram, what it is saying. So if you see in the question, they are saying that a spring is attached to mass, right? Another is fixed at the support. It is stretch and release. So initially what will happen, if you see this spring, let us consider that this is the support and there is a spring. This spring is right now hanging. So we already know that there is some elongation. Let us say that this is the natural position, natural length. Natural length is L. Okay. So there is already some elongation which you can write as x naught. X naught is some elongation. So this x naught is happening here, this elongation. So right now body is in equilibrium. So this is the equilibrium position, equilibrium, or you can say mean position, right? Now they are saying that you are stretching it further. Let us say that you have stretched it further, and if you release, suppose you are stretching it and it has come here, let us say, and you are releasing, so that means you are releasing from this position and body will start moving up, right, with initial velocity 0. And you know that this is the extreme position and that is the mean position. This is extreme position, this is mean position, and let us say that this distance is a. So it will also go a distance that side, it will also go a distance that side. It may come to the natural length or it may go beyond that or it may come before that, but whatever is the case, it will be stopping there. Let us say that it has come here. This is the extreme position. Another extreme position, another extreme position, right? That means this distance is a, let us say. So here also speed will be 0. So the body is going to oscillate between these two extreme position and with this mean position, right? So note that this was the original position. Where is the original position? Here, this is the original position, right? And from this position we have stretched it. So here it was at rest, and initially it was at rest, but we have pulled it now. And while you are pulling it, you are leaving it here. So while you are leaving it here, it is going to start from this point. Note that it is going to start from this point, not from that point. There can be a confusion. You are starting this from this position. So you have stretched a distance of A and then you are releasing it. Okay. Now try to explain the answers. Now try to understand this. So what they are saying, that magnitude of acceleration when just release is maximum. So you have just released it. That is the extreme position, right? And at the, so it is SHM, you know that it is going to be SHM. So when you have released it, it is extreme position. So definitely acceleration is maximum. We don't have to do much here. So we can say that acceleration is maximum when you have released it, magnitude of acceleration, because it is the extreme position, right? Magnitude of acceleration when at equilibrium position is maximum. Equilibrium position, we know that equilibrium position force is zero, so we don't have any acceleration. So this is anyway wrong. This is going to be wrong. This is not correct. Next, speed is maximum when mass is at equilibrium position. When the block comes to the equilibrium position, the speed is maximum. Definitely, no, at the mean position, you know, the speed is maximum. So this is correct. Then magnitude of displacement is always maximum whenever speed is minimum. Now try to understand that whenever speed is minimum, always displacement magnitude is maximum. Try to understand this. Body has started from here. Note that this is the starting position. This is the starting position. Starting position. So you are measuring displacement from the starting position. Generally what happens is that in SHM we measure displacement from mean position, but in this question we should not assume that no displacement is given from the mean position, because we have to consider displacement from the starting position, right? And starting position is the extreme position, right? Now they are saying speed, whenever speed is coming zero, there is maximum displacement. So right now let us say here this is original position here, and speed is zero here and here, extreme position. So here speed is zero, here displacement is zero, note that. And when it comes to another extreme, displacement is definitely maximum, right? Displacement will be 2a, and once again it will come at the same position, this extreme, again you know displacement, but the speed will be zero, but displacement will be zero. Then displacement will be zero. So note that when you are taking you know calculations from the starting position, so speeds are zero at this extreme and that extreme, but it is not always this is the like zero speed is the maximum displacement. Yes, zero speed is maximum displacement for that extreme position, not for this extreme position, because it is also coming here again, right? So speed is zero here also, but here displacement you can say is zero, or you can say minimum displacement, right? So you can say here in this question that this position, this extreme position is the minimum displacement, minimum displacement, minimum displacement, and this position is the maximum displacement, maximum displacement, maximum displacement. So zero speed happens in both cases, both at minimum displacement and maximum displacement. So we cannot say always that zero speed will happen at maximum displacement, right? This is an important point to note. Fine. So that means this one is not correct. Option D is not correct. Otherwise, it could have been correct if they are considering starting from the mean position. Starting from the mean position, if they consider, then you know the whole question will be different. In that case, suppose the question is like that: you have this equilibrium, right? This equilibrium. Let us consider that, and from this position it is moving. This position it is moving. So, or you know you have hit it somehow and with something, so that it has started motion from the mean position. In that question, you know the zero position is like the maximum displacement position, because you are starting from the mean position. That's a very minute thing, but it is important to understand that. Okay, then let us go to the next question. Question number 11. A ball is bouncing elastically with a speed of 1 meter per second between walls of a railway compartment of size 10 meter. In a direction perpendicular to walls, the train is moving at a constant velocity of 10 meter per second parallel to the direction of motion of the ball. As seen from the ground, the direction of motion of the ball changes every 10 seconds. Speed of ball changes every 10 seconds. Average speed of ball over Any 20-second interval is fixed, the acceleration of ball is the same. Okay, let us try to understand what is this scenario. That there is a ball which is bouncing back and forth, back and forth. Elastic collision is happening. Speed is 1 meter per second between walls of a railway compartment of size. Let us draw that. Suppose if I draw, this is a compartment, railway compartment. Okay, railway compartment. And let us say that the ball, there is a ball which is bouncing back and forth. So this ball is going like this. It will be hitting it. After that, after hitting it, it will be bouncing backward in this direction. So this is keep on happening, and they have given the speed. What is speed? It is 1 meter per second. That is definitely relative to the compartment. And size is 10 meters. Size is 10 meters. So this size is 10 meter, and this speed is 1 meter per second. What else is given? Train is moving at the train is moving at 10 meter per second. This whole train or the compartment or the bogie is moving with 10 meter per second. And we need to study the motion of the ball with respect to the ground. Note that with respect to ground. You may also study with respect to this frame of reference, right? And note that they are going, this is moving with a constant velocity, so definitely there is no acceleration of this. It has zero acceleration. This is also like an inertial frame of reference, right? Because it doesn't have any acceleration, so this whole compartment or the train is like an inertial frame. Okay, let us take this question now one by one. The direction of motion of the, as seen from the ground, direction of motion of the ball changes every 10 seconds. Every 10-second motion of the ball is changing. Let us try to study the motion of the ball. So if you study with respect to this frame, if it is going with a relative velocity of 1 meter per second, so from this frame, it is going to take 10 seconds, right? So for this, from this frame, if you consider time is equal to distance by speed, so 10 seconds. So this 10 second, every 10 second it is changing, but this is with respect to this frame, train frame. With respect to ground, what is happening? Now let us try to calculate with respect to ground. Let us say that it has started from here. So how much time it will take to reach from here to there? How much time it will take? Yes, can we calculate that time? So this ball is going to collide here, right? This collision will happen in 10 seconds. So in 10 seconds, does its means relative motion is of course changing, but with respect to ground, how can we calculate that with respect to ground? Because this is also moving. 10 meter per second it is moving, and this is moving with 1 meter per second. With respect to ground, if you calculate what is the velocity of this ball, let us say the ball is going forward. Okay, so the velocity of ball with respect to ground will be velocity of ball with respect to train plus velocity of train, right? Can we write like this? So forward is 1 meter per second, and that is 10 meters, so it will become 11. So 1 plus 10 will become 11 meter per second. So with respect to ground, if you are seeing that ball is actually moving with 11 meter per second, and train is slow, train is moving slowly, 10 meter per second. So that is why this person will be able to see the collision happening. First collision, let us say it happens. How much time first collision will happen? And after the collision, what will happen? That also you see. Let us say some collision happens. That collision happening is 10 seconds, that's right. Collision will happen in 10 seconds. But after collision, what happens? This velocity reverses and it is 1 meter per second. But as soon as this velocity reverses, then this is the forward motion. Let us say forward. And when it is backward motion, let us consider backward motion. Backward motion. So velocity of ball is what? Same formula, but relative velocity has become minus now. So minus 1 plus 10 you have to give. So that is plus 9 itself. So see, with respect to ground, if you see this forward backward, you have seen with respect to this frame, but with respect to ground, you see it looks forward backward, but both direction of velocity is same, plus only. So even in 10 second, it looks like direction is changing, but this is with respect to train frame of reference, not from ground, because with respect to ground it is means forward it was 11 and backward it is 10, so it is not changing, it is not looking to be changing its velocity, right? Its velocity is not changing. In direction, magnitude is definitely changing, but in direction it is not changing. Direction is changing for relative motion when you study with respect to that frame. Okay, so that means what? This direction of motion of the ball changes every 10 seconds. This is not going to be correct. Yes, direction of motion of the ball changes every 10 seconds. With respect to ground, we are starting, so this is not going to be correct. Speed of ball changes every 10 seconds. Yes, we can see that, because whenever collision is happening, sorry, this one, whenever collision is happening, right, in 10-second collision is happening, but in that 10-second, the relative velocity changes, direction changes, but magnitude of relative does not change. But with respect to ground, direction does not change, but magnitude changes. Magnitude changes, speed changes. So speed of ball changes every 10 seconds. This is correct. Yes. Then average speed of ball over any 20-second interval is fixed. Average speed of ball over any 20-second interval. Average speed. How to calculate average speed? Average speed is total distance by total time. Let us calculate average. Total distance, let us consider L by total time t. So here in this case, they are saying for 20, average speed of ball over any 20-second interval. Let us say 20-second interval. So you have started from here to here. So first 20-second, if you take uh, here to here, relative direction is definitely changing, but its direction is not changing. So what is the distance? What is the distance? How can we calculate distance? Yes. Let us say for relative, how do you calculate the distance? Delta L of the ball we are calculating, delta L of the ball. Note that with respect to ground, when you are seeing, the direction is not changing, so during the forward motion which is taking place with 11 meter per second, right, 11 meter per second is going for 10 seconds, and backward motion is 9 meter per second for 10 seconds. So how much distance will be traveled? Distance is forward speed into time 10 plus backward speed 9 into 10, right, divided by time interval 20. So how much this comes out? Check out this. This you can cancel definitely. This become 20, correct, by 2, that means 10 meter per second. So this average does not depend at what time you are taking, because forward 10 second, backward 10 second, right? For any interval of 20 second you are taking. So for any interval of 20 second, if you take, this will be the same. This will be the same. You may graphically also interpret it, but it will be going to come as same, right? Okay, so forward speed, backward speed, only thing is that speed is changing after uh, after 10 second, but the direction is not changing, so it is going in the same. With respect to ground it is, right? So yes, this is right. This answer, option C, is also correct. It is fixed. Acceleration of the ball is the same as from the train, as from the train, same. So train acceleration with respect to train and acceleration with respect to ground is same, because both are inertial frame, right? We have seen the train is not under acceleration, so the relative acceleration is going to be same, because here acceleration 0, and with respect to ground also it is having same acceleration, right? If it was under acceleration, then there will be a pseudo acceleration which we have to see with respect to this frame. but with respect to ground it will be accelerated motion, right? So in this case we can say that acceleration is definitely the same. So we will have answer as um, B, B, C and D. A is not going to be correct, right? Then let us go to the next. Question number 12. Refer to the graphs in the figure. Match the following graph characteristics we have to match. Okay. So first has velocity positive and acceleration negative throughout the motion, right? What about the velocity and acceleration they are asking? So velocity means slope of the graph. Let us see the slope of the graph. Slope. So everywhere slope, if you see here everywhere positive, but here slope is becoming 0. Here slope is becoming 0 means velocity is 0, and after that slope has become negative. So here velocity is positive 0 and velocity is becoming negative. So velocity uh, positive and acceleration negative throughout, this is not correct. What about acceleration? What about acceleration? So because the shape of the graph is convex shape, acceleration is negative. This part is correct. This part is correct, but this part is not correct. Why? Because velocity is changing, right? Next, uh, second one, has x positive throughout and has a point with velocity 0 and a point with acceleration 0. Second, B second, right? That means second one has x positive. X is positive everywhere we can see because the graph is above the time axis. Means in positive direction it is, right? Throughout and has a point with velocity 0. Yes, because we can see that here at the peak velocity is 0. Definitely velocity is 0, right? And has a point with acceleration 0. They are also saying that acceleration 0. So acceleration 0 means where the shape of the graph is changing. If you look at this graph, this shape is convex shape, and here definitely shape is becoming concave. So definitely this is the point where acceleration is 0. Yes, so this second one means B. This is definitely correct. B1 is correct. Okay. What about the C1? Has a point with 0 displacement for time greater than 0. Has a point with 0 displacement. 0 displacement they are saying. So you can see here the position is all positive, positive, positive. Anywhere it has not come to the same position. If the body comes to the same position, right? For example, if the graph is like this, let us say position time graph is like this. Position time graph is like this. Then in that case, what happen is that, so at some point it is coming to the same position, right? Then you can say displacement is 0, but that graph is not like this, right? So we can neglect this. This is not correct. Okay. Then what about the fourth one? Has velocity negative and acceleration positive. So what about here velocity? So slope is positive only. Slope is positive. So velocity is positive. So this is not correct. What about acceleration? Acceleration is again negative convex. So this is also not correct. That means anyway it is wrong only. But we can analyze that both part are wrong, right? Fine, let us move to the next question. Question number 13. A uniformly moving cricket ball is turned back by hitting it with a bat for a very short time interval. So the variation of its acceleration with time, take acceleration in the backward direction as positive. Suppose, for example, if a ball is going with some velocity, after that it has been hit by some bat or something or some wall, right? And then what happens? Its motion changes. Motion changes. What about the speed? The speed changes or not changes? Uniformly moving cricket ball is turned back by hitting it with a bat for a very short time interval. So the variation of its acceleration with time. Let us say that the speed also changes, v1, v2. So that means definitely velocity changes, both changes. Take the acceleration in positive. This direction you consider as positive. this direction is taken as positive and this direction is taken as negative. Okay, right? Like this we have to do calculation. So we have to show the variation of acceleration with time, acceleration versus time graph. And this collision is happening for a very small time, very small time. So let us try to draw this graph, time graph. So the variation of acceleration with time. So this is acceleration versus time. So initially it is going with constant velocity. So if velocity is constant, so acceleration 0. So if I draw this graph, initially for some time it has traveled. Let us say like this, and let us say at this instant it has hit the wall. So at that instant, what happens is that what happens to the acceleration? What happens to the acceleration? There will be acceleration in this direction, right? Because this direction forces is acting, so acceleration will be in this direction. Velocity has changed in this direction, so acceleration will be positive. But they are saying a very small time. Suppose this is a very small time, very small time. Let us consider delta t. Delta t is the time interval during contact. Delta t is the time of contact. Okay. So during this time of contact, what do we consider as the acceleration or the force? Will it be constant or will it be variable? So the nature is very important here. So here it goes like a maximum value. You can consider it's very sharp peak, and then it will be coming like this. After that, what? After that, again it will become constant, because again it will be not changing. So you can see that a very sharp peak will be there in between, like this. After that, it is not changing, right? So why it is showing like this, why it is increasing? Because what happens is that the force is also a variable force. The force which is acting during the time of contact or impulsive force is considered as a variable force. Initially it is increasing, and once it is completely deformed, then force stop and then force reverses in that direction, right? So in this way it will be changing, correct? So think about force is acting in the same direction, but the magnitude will be changing. Suppose this is the ball, and as soon as it comes in contact with this, we have taken that contact has started at this point. Before that, let us say it was traveling from some distance, d distance. Okay, so this is a time from here to here. This time you can take as distance by speed v1. Okay, like that you can take after. Otherwise you can start this graph from here also, if you consider that time 0 it is in contact. Okay, according to that you can do that. Fine. So this graph will be like this. The nature of the graph, why it is like this? Because the force which is acting here, force will be acting only in this direction, but this force which is equal to mass into acceleration is a variable force. It is not a constant force. It's a variable force. Like this is the nature of the graph. Okay, let us move to the next. Give examples of one-dimensional motion where particle moving along positive direction comes to rest periodically and moves forward. Right? Let us try to give example of one-dimensional motion where the particle moving along positive x direction comes to rest periodically. Periodically, it comes to rest and moves forward. Note that it is moving along positive x direction. Can we consider the case of the example of the collision itself? But in the collision, the direction will change. Direction of motion of velocity changes. But here they are saying that the particle is moving along positive direction, comes to rest. It is coming to rest periodically. Is coming to rest. Okay, that means after regular interval coming to rest, and moves forward. Moves forward means what? Is it moving in the same positive direction? Because because this can be confusion, right? Forward backward means what? Do I assume that forward means positive direction, right? Then how it is possible? Think about it. They are saying that a body is moving in this direction, right? Positive direction, moving, and it has stopped. It has stopped, and then again moving forward, the same direction, and then again stop, and again moving forward, and then again stop. Like this type of motion, it is happening. Periodic motion it is. Where do we see that kind of motion? If I can say forward means same direction, where it can happen? In real life. Yes, in real life, can it happen? You may assume that, let us say, a bus is going forward or train is going in the forward. Of course, train and that railway track cannot be considered as a straight. It is lot of turns are there, right? But if you assume it's a straight line motion, then this train will start from here, it will stop here again. Next station it will stop, next station it will stop. You can assume like that, right? Okay, then next, the particle moving along positive x direction comes to rest periodically and moves backward. Particle moving along positive direction comes to rest and moves backward. This example we can take, for example, if you are dropping a body, let us say you drop, and consider that some collision is happening. So here you have dropped it, speed is 0. After collision, let us say it has collided with speed v1, so it will come out with some velocity v2, and it will stop here. And if you consider the elastic collision, then it will come to the same height, then the time period will be same. But if you consider in real life, if some loss of energy happens, it will come to stop to a different time. So time may not be the same. Then again the collision will happen. Then again it will come up, and then it will stop here. So like that it will keep on stopping here like this. Okay, like this it will keep on happening. But periodically we cannot say that, because we cannot define as such like period. Only if you consider elastic collision, then we can consider period. But in real life, we cannot have elastic collision, right? Correct. We cannot have that. Of course, direction has changed, so motion is changing like this way. Fine, right? You may also consider collision with the walls, and there you can consider that during collision temporarily it stops. Temporarily it is stopping, because for a very small interval of time impulsive forces are acting, and it is getting stopped instantaneously. That also you can consider, right? Let us go to the next. Give example of a motion where x is positive, velocity is negative, and acceleration is positive at a particular instant. At a particular instant. Think about it. What they are saying, that body is moving in the positive direction, velocity is positive. Okay, I think you can consider the upward motion of a ball. This is ground. So the position of the body is in upward direction. So this x is positive. X is positive. This I am taking x is equal to 0. Ground is x is equal to, so x is positive. Always x is positive. It cannot go inside the ground. And velocity is positive only in the upward direction when it is moving upward. In this case, velocity is positive. Acceleration is always negative, because it is retardation. So acceleration is negative, which is minus g you can take. So this is the case, right? What happened in downward journey? Downward journey velocity will be negative, but x will be positive. Note that in the forward journey only velocity is positive, and in the downward journey velocity will be negative. Everything else will be same. Acceleration will be negative and x will be positive, right? Then let's go to the question number 16. Object falling through a fluid is observed to have acceleration where g is gravitational acceleration and b is constant. After a long time of release, it is observed to fall with constant speed. What must be the value of that? This constant speed is what is called terminal velocity. Many places we have seen the idea of terminal velocity. Terminal velocity they are asking, right? So note that terminal velocity means where equilibrium achieves. Equilibrium means acceleration becomes zero. This quickly you can solve it. Nothing is required in this because terminal velocity, if you want to calculate, then acceleration has to be taken as zero. And just you will equate g minus b into v is equal to 0. That v will become g by b. It's not difficult portion they are asking terminal, but if they ask something else, right, they may ask like how the velocity changes with time. Can we draw the velocity time graph? Can we draw the velocity time graph? So let us try to do that. Velocity time graph, if I draw, and let us consider that it is going in the downward direction and this direction is the positive direction. Initially you may have released it, so its speed will be 0. Speed is 0, you have dropped it, so after some time it will attain this terminal velocity, which is a constant velocity g by b. Let us call it as terminal velocity vt. But before this time also, what time it will have? Suppose time 0 it is. What time? Let us say t is equal to t1. What is the time when it achieves that? That can be a question. And also, um, how does instantaneous velocity somewhere when time is t? How does this velocity v is changing? How does v velocity changes with respect to time? That's how we have to draw that graph, right? So after this time t1, velocity is going to be terminal velocity. So you can consider that this velocity will be constant. But before that, so starting from here to here, what type of graph will be? It's an interesting thing. Try to think about it. So if I consider this as the acceleration, so can I write acceleration as dv by dt, and this is g minus bv? Then can I write dv by g minus bv is equal to dt and try to integrate? Yes, it will give some expression. Try to do that. So if I take initial velocity is 0, final velocity v, this time is 0 to instantaneous time t we are taking. So this will be t. Here integration will give ln g minus bv, right? And its coefficient minus b will come. And it is going from 0 to v. This will be t. So from here, this minus bt you take that side and it will become ln, put upper limit and lower limit, so it will become g minus bv by g is equal to minus bt. So from there, try to calculate e per power, you bring it, and then this is 1 minus, right, it will become 1 minus bv by g is equal to e power minus bt. So what will be v? V will be equal to g by b 1 minus e per power minus bt. Now this is a very nice expression, like this. Okay, and it is attaining that speed. And note that when time is 0, it is 0, and when that time becomes that t1, then it will, you can also calculate that, right? We can calculate that time t1 also from here, because v you have to substitute at g by b, and this will become 1, right? 1 minus this, that means this time is very long, very large time this time, because only when this become very large, infinity per power minus infinity becomes 0, then it will become 1. So this time t1 is very long. You can consider this time t1 is like almost infinity, it is. Okay, then what about this nature of the graph in between? So you can try to differentiate also. If you try to differentiate, which will be basically the acceleration. Now, is the slope positive or negative? That you can try. You can try from here also. G by V comes out. Differentiation of this one is 0, right? This minus comes out, e per power this become e per power this only, minus will come, plus will come. So positive slope is there definitely. What about double differentiation? Double differentiation will be coming negative. Because of that, you can check that. So negative means what is the type of the graph? This graph shape will be convex shape. This is very important to know that this is how it will be. Okay, so this point itself is very large, so you can say like it is becoming parallel to that. Parallel to that line it will become. Fine. So I hope you have got this. It's a very good question, standard questions for JEE Advanced. Like that type of problem is coming. So NCERT example questions, rocking, right? It's rocking questions which are truly, truly made for advanced type, advanced material it is. But we are neglecting it. We are thinking NCERT doesn't carry more importance, but it is carrying all importance. Only thing is that we need to change our opinion, our view, and we have to take the questions seriously to work out, all questions from all point of views, right? Let us go to the next. 17, question number 17. A ball is dropped and its displacement versus time graph. Okay, so displacement versus time graph is given. X is from ground. Okay, x is the distance from displacement from ground. All quantities are positive upward. Plot qualitatively velocity versus time graph. Now based on this we have to plot velocity versus time graph. So if you consider here, x is first of all decreasing, that means it has been dropped, right? And initially you can consider like a peak point, so initially velocity will be 0. Then what? Velocity slope of the graph is negative, so velocity is increasing, right? It is dropped. So suppose for example there is a ball and you have dropped it, initial velocity 0, so it will be hitting the ground, right? Hitting the ground after plot qualitatively velocity versus time graph. So at an instant velocity here, at an instant v is equal to u plus at, so v equal to gt will be there. What about the downward direction? Upward is positive, so downward will be negative, so we have to write this as minus gt, right? So let us try to plot that graph. Velocity versus time graph. So velocity versus time graph, this graph starting point initial velocity is 0. Initially velocity is 0 and after that minus gt means it is like this way. Up to some time where collision with the ground happens. After that what happens? After collision it is going up, and also note that it is not able to travel the same. That means the collision is decreasing the speed. So speed will be decreasing after collision, but speed will be positive now. So it will be positive, right? Speed will be positive after, just instantaneously, just after that. So speed will be positive, but what about velocity? Velocity is in the positive direction, right? Because after collision it will be moving in this direction. But what about the velocity? Velocity will be increasing or decreasing? It will be decreasing, right? And again it will become 0. So this graph, note that you need to keep on drawing a line parallel to this, because the slope will gives acceleration, which is a constant acceleration. So try to draw a parallel line like this. But this time it will be coming. Now question is that suppose it has gone here, from here it has gone, and it will be going in a different time. It will take different time definitely. So here it has come, let us say for example here. Then again the same story will repeat. Now it will be repeating like this way, like this, like this. Qualitative graph, no, I am not calculating any values here, but the graph, nature of the graph, all these lines are parallel lines. Okay, and the gap distances between them has to decrease because time will be smaller, right? Okay, then what? Plot qualitatively acceleration versus time. Acceleration is not going to change. Acceleration is downward only. So if I have to plot acceleration time graph, acceleration versus time graph, I will simply plot a constant and negative acceleration, which will be like this, which value is minus g, right? That's a very simple, plot. Fine. So I hope you got this. Then let us move to the next question. Number 18. If particle execute motion described by, okay, some equations are given, looks like very complex equation. Where does the particle start and with what velocity? The question is, where does the particle start? Where does the particle start? And with what? Where means what is the position? I think position. Hmm. So where does the particle start means first velocity we have to calculate, and you have to keep velocity 0. There only it starts. First calculate velocity. It is calculate velocity. So velocity is dx by dt. Let us do this differentiation. So x naught comes out. Differentiation of 1 is 0 minus e power differentiation is same, right? And then differentiate minus gamma t with that. So minus gamma comes out. So it comes out as x naught minus plus gamma e power minus gamma t. Right. So when is velocity 0? Can we guess when is velocity 0? Velocity doesn't seem to be 0. Only when time is infinity, then only we can take that. What about gamma? Another things are the gamma. Assuming gamma is positive, right? All these things are positive. So velocity can be 0. Velocity can be 0 when time is infinity. Okay, and when time is infinity, what is the position? That calculate. When time is infinity, what is the position? X naught 1 minus e power minus, here infinity, this term is going to be 0, right? This term has to be 0, so 1 minus this 0, that means x equal to x naught. So the question is, where does the particle start? Where does the particle start? So particle start means where velocity is 0. So velocity is 0. And with what velocity? Then why are they asking velocity? Where does the particle start? What does that means? Particle start means, should I not consider that velocity is 0? Start means what? Should I not consider velocity 0? Then why are they asking velocity? So are they asking something else or what? Where does the particle start? Suppose if I consider time equal to 0, let us consider time 0. Time 0 means initial time. Time 0 if I consider, then x is going to be x naught 1 minus 1, then it will become 0. So time 0 position is 0. What about velocity? Velocity we have seen here, right? So at that time when you put time 0, that initial velocity, which you can write as u, initial velocity u, that will be x naught into gamma. So are they asking about this, or are they asking this is different, different interpretation, because things are never clear in the question. Now you can have multiple interpretation, all those things can be correct. It depends how are you taking things, right? So where does the particle start and with what velocity? If they are asking where does the particle start, means particle start means velocity should be 0, then why are they asking velocity? So maybe they are asking this condition at time 0 what is position and time 0 what is velocity. So this will be what? Time 0 position is 0, time 0 velocity is this. Maybe they are asking that. Okay. Then what next? To find maximum and minimum values of this x, v and a. First try to find maximum values of x. Maximum values of x means what? When this will be minimum because you are subtracting. Minimum can be, this can be 0 when time is infinity. So maximum value of x will be x naught only, right? What about maximum value of velocity? Velocity, if you see, this is velocity. Maximum value will be what? So maximum value of this e per power this, and e per power minus it is, right, decreasing. So maximum value means if you can take time 0, time 0 1. So this is maximum value, right? So what is maximum value? Let us write maximum value. And also acceleration they may also differentiate once more. Acceleration dv by dt you have to also do. So if I differentiate this, we'll get x naught gamma, and again minus gamma will also come, gamma square e per power minus gamma t. So if they ask accelerations also, now let us try to find out. So if we have to calculate maximum value of x, maximum value of x is x naught. What about maximum velocity? Maximum velocity. Maximum velocity is x naught gamma, right? Which is initial velocity. What is maximum acceleration? Maximum acceleration. And they are also asking minimum values. What about minimum value of this? Minimum value. Minimum value means what? This will become 1, so this will become 0. So x minimum will be 0. X minimum will be 0. Correct? It cannot be negative. X cannot be negative. Anyway, they have given also x is positive. So minimum value of x is 0, maximum value is x naught. What is minimum value of velocity? Velocity minimum value, we have seen at time infinity it will be 0. So minimum velocity will be 0. What about acceleration? Maximum value of acceleration. What about acceleration? Maximum and minimum value. Acceleration minimum is how much? Minimum acceleration. Here also, note that acceleration is coming here negative because this term is going to be positive, right? So minus acceleration is negative only. Acceleration is negative only. So minimum what can we take, and maximum what can we take? Maximum we can take like 0, and minimum what you can take? Minimum we can take what? Because this value will become, you can take for example time 0. Time 0, if you see, this is starting with negative acceleration, and as time increases this negative value decreases, and when time becomes infinity this becomes 0, right? So minimum acceleration and maximum acceleration, note that maximum acceleration can be 0 and minimum acceleration will be when time is 0, so that means minus x naught gamma square, right? These are the maximum minimum. And if I have to plot the graph, how should I plot the graph? Let us plot the graph. Plot the graph of x versus t. Plot the graph of v versus t. Plot the graph of acceleration versus t. Try to plot the graph. So you know x equal to x naught 1 minus e per power, right? X is equal to x naught 1 minus e per power minus gamma t. Right, so time 0, if you take time 0, x is 0 and maximum value is x naught. So it is going to become this value at infinity. Note that this graph will be like this. At infinity it will achieve the maximum value. So what about v naught? V naught, we have seen the graph. What about v? When we differentiate it, we have got this what? X naught gamma e per power minus gamma t, right? So when time is 0, this is maximum, x naught gamma. After that what happens? Time increases, it is going to become 0. So this graph is going to be like this. Note that this will achieve its minimum value, which is 0 at infinity. It will become parallel to this, right? What about this graph acceleration? Acceleration we have seen, acceleration is minus x naught gamma square e per power minus gamma t. So at time 0, acceleration is starting from negative, right? Negative side it is starting. So acceleration graph, if you consider here, somewhere here, which is minus x naught gamma square, and this acceleration is going to become like this at infinity, it will become 0, right? So from the graph we can clearly see very nice graphs are there, very important. It has got applications, particularly just like previously we have seen, right, one question. So you can see two similar model of questions are getting repeated. That means it's a highly important topic for J main, J advanced, highly important topic. This is in the case of, drag. Some drag forces are there, like in case of fluids, right? Highly important. A bird is tossing, flying to and fro between the two cars moving towards each other on a straight road. One car has a speed of 18 km per hour while the other has a speed of 27 km per hour. Bird starts from the first car towards the second, right? Moving with this speed, bird is moving with this speed. And when the two cars are separated by 36 km, okay, that time the bird starts moving. What is the total distance? What is the total displacement of the bird? Let us try to do this calculation. Suppose that there is a car A and this is a car B. The separation between them is how much? 36 kilometers. And the bird, this bird is going with 36 kilometers per hour. What are the speeds of these buses? First is going 18 kilometers per hour, another is going 27. So this is going with 18 kilometers per hour and this is going with 27 kilometers per hour. Right now they are saying that this bird is just tossing between this. So it starts here, it goes to B, then after landing immediately it returns back and it is going with the same speed. So after going to B it comes to back A, again B, again A, again B, again A, like that till they will meet, right? Till they will meet. So what is the distance, total displacement of bird and total displacement of the bird? How do we calculate it? Let us try to do that. So first of all, we know that A and B are going with some speed and they will definitely meet after some time. So when it will meet, that time we can calculate. So time when they are going to meet, time for meeting A and B, time is equal to distance 36 kilometer by how much is this speed? You add relative speed. So 36 by 45, 4 by 5 hour. So they are going to meet in 4 by 5 hour. So the bird will keep on flying between them till they meet, right? So for the distance traveled by the bird is equal to distance speed into time directly. So speed is 36 into time is 4 by 5. Correct? This is in kilometer per hour. If you want, you can bring it into meter per second. Let us bring it in meter per second. So I will multiply with 5 by 18. So 5, 5, 18 into 2. So 4 into 2, 8. 8 meters. So 8 meter is the total distance traveled by the bird. What about displacement? Displacement traveled by the bird. How do you calculate displacement? How do you calculate displacement? So when they will meet, somewhere in between they will meet and bird will also be meeting that point, right? Suppose both of these are meeting somewhere here. So this has this bus has traveled from here to here. That will be the displacement of the bird also, because bird also started from the same place at A, right? So they will, both the cars will meet here, and bird also will be here only at that place. So what will be this one? This is the displacement, right? So this displacement is same as the displacement of car A, right? What is that displacement? So its speed is how much? 18. So displacement or distance is equal to speed into time. So this is speed 18 kilometer per hour, and this time is how much? 4 by 5. 4 by 5. Again, if you want, you multiply 5 by 18 to convert it. That means 4 meters. That means exactly in between it will be meeting, right? Exactly in between it is going to meet. Correct, because displacement is equal to its velocity into the time when they are meeting. So its velocity is 18 kilometer per hour, and time is 4 by 5 they are meeting. So when you multiply 4 by 5 and you have converted into that. Correct. So displacement is exactly half of that. So fine, I hope you have understood this question. But suppose if they ask how many trips the bird will take to meet it, that's a wonderful question. Now, if they ask how many trips the bird will take, before they meet, before the cars meet, that is, calculation is a little bit tricky, but the pattern in which you will do calculations, that will form a geometric series. How it will form a geometric series? Because first of all, you need to consider that bird will be traveling from here to here, and then the distance has also already decreased. Then time again, so time will keep on decreasing, right? Time will keep on decreasing for every trip. So first trip, when it takes, time will be larger. Second trip, time will be less. Third trip, time will be further less. So like that, you can find out that it may take infinite number of trips. Infinite number of trips it will take. But the total addition of all that time which you are going to take is going to come finite. That's a very important concept for JEE Main as well as JEE Advanced. That although it's a finite, time, but the number of trips is infinite. Number of trips is infinite. It's a good idea. There are certain standard questions on that which you can look for. Certain books like S.C. Verma solved problems are there on that. You may go through that. Fine. I hope you got this question right. Thank you.